And this is a typical notice, copyright. We continue with mathematics syllabus for CSEC, and that would be 2018 to 2027. Schedule of videos. I had originally said that I hope to have all 32 videos in this section published by September 24th, but right now I'm running a little late on this schedule, but hopefully by the time we finish section 2, October 2024, we will be back on schedule. Then November sets, December by the end of the year 2024, measurement, January 2025, statistics, February, algebra, March, relations, functions, and graphs, April, geometry and trigonometry, and by May 2025, by mid-May, hopefully, vectors and matrices. As I pointed out before, I have divided section 1 in 32 videos. It is now 33 videos because I missed one of the objectives, all of which will be made available on YouTube in their entirety. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will be able to do with the rest of the syllabus. So please make sure you view and understand these first 33 videos from section 1. So we completed those 16, and they are all published. As of now, we are here, objective 110. That's the one that I somehow overlooked. And so I will let this video be video 24, so that 24 becomes 25. And by the time you get down here, that 32 becomes 33. So this is the objective that I overlooked. Use properties of numbers and operations in computational tasks. We finish those two up there. Then we are now doing this one. And after that, of course, we will do this one. Write any rational number in scientific notation. So those two were completed. This is the one we are doing now, and that will be the next one. So the objective actually states, use properties of numbers and operations in computational tasks. And then it goes on to list what properties and operations you are required to know about. Closure, that's the first one, and we will follow this in sequence. Associativity, additive identity, additive inverse, multiplicative identity, multiplicative inverse, commutativity, and distributivity. So there are 8 concepts there that we will look at. Now it does say to use them. This video, though, we will just be considering what they are so that you can recognize them and then use them during the rest of the coursework. So let's begin with closure. Of all these 8, this is maybe the most difficult to recognize and use. So what it says is this. Closure property states that if you perform an operation on any 2 numbers in a set, the answer must be another number in the same set. This holds true for addition and multiplication for real numbers. So let's look at some examples. 5 plus 3. If you look at them carefully, these are all natural numbers, and so your answer must be a natural number. Next one. 8 multiplied by 0. Those are now whole numbers, and so your answer must be a whole number. Negative 12 multiplied by 2. These are integers, and so your answer must be an integer. 8 multiplied by 1.4 equals 11.2. These two are rational numbers, so your answer must be a rational number. And then 22 over 7, which is an irrational number, plus 19 over 3, which is a recurring decimal. So together, they belong to a larger group of real numbers. So your answer will be a real number. This is probably the hardest to recognize and to apply. So now we are going to look at associativity. Regrouping elements by associating them with different elements without moving them does not affect the result for addition and multiplication. For example, if you have B plus C and you add that first and then you add it to A, or if you add A and B first and then you add it to C, you will get the same answer. So let's see. 5 plus 2 plus 4 is the same as 5 plus 2 plus 4, which is 11 in either case. Next, 8 plus 3 plus 5 is equal to 8 plus 3 plus 5, which gives us 16. 8 plus 3 plus 5 plus 4 is the same as 8 plus 3 plus 5 plus 4. We still get 20. Next, 4 multiplied by 2 times 3 is the same as 4 times 2 multiplied by 3. We get 24. So associativity. And 5 multiplied by 2, if you do that first and then you multiply by 6, or if you multiply 2 by 6 first and then you multiply by 5, you will still get the same 60. Thirdly, additive identity. Now, additive identity is any value which, when added to a number, results in the original number. Now, the only value or number that can do that to any real number is 0. Therefore, 0 is the additive identity for real numbers. Let's look at a few examples. You know this already. 5 plus 0 is equal to 5. 3 plus 0 is equal to 3. 7 plus 0 is equal to 7. 4 plus 0 is equal to 4. And so on. You get the idea? Additive identity is fairly easy to understand and to recognize. Next, we are going to look at additive inverse. This one is a little harder. The additive inverse is the negative of any value which, when added to the original value, returns the value of 0, which is the identity element under addition. So as I said, this one is a little harder to understand. Example, 5 plus negative 5 is equal to 0. 2b plus negative 2b is equal to 0. Minus 7 plus 7. The negative of negative 7 is, of course, plus 7. And that would give you 0. 2a squared plus negative 2a squared would give you 0. and negative 23.45 plus positive 23.45 is equal to 0. Remember I said it is a negative of any value. So if you take the negative of negative 23.45, you get positive 23.45. Now the value that brings you back to the identity element under addition. Remember we said 0 is the identity element for addition. And so on. I think you should get this idea by now. 5, multiplicative identity. This one is fairly easy too. The multiplicative identity is any value which, when used to multiply another number, results in the original number. Now, the only value or number that can do that to any real number is 1. Therefore, 1 is the multiplicative identity of any real numbers. Let's look at some examples. 5 multiplied by 1. What do you get? 5. Negative 3 multiplied by 1. What do you get? Get back negative 3. 76.95 multiplied by 1. What do you get? 76.95. Get back the same answer. 412 multiplied by 1. What do you get? 412. And so on. I don't think I need to go on with this. You get the idea. 6. Multiplicative inverse. Now, this one is a little more complex than the one we just looked at. The multiplicative inverse is the inverse of any value which, when used to multiply the original value, returns a value of 1, which is the identity element on the multiplication. So if you multiply 5 by 1 over 5, you will get back 1. If you multiply 2b by 1 over 2b, you will get back 1. If you multiply negative 7 by 1 over negative 7, you will get 1. If you multiply 2a squared by 1 over 2a squared, you will get 1. And if you multiply 6 by 6 over 2, you will get 1. So the value that brings you back to the identity element on the multiplication. And so on. Commutativity. The commutative property applies to arithmetic operations for addition and multiplication. It means that changing the order or position of two numbers while adding or multiplying them does not change the end result. So let's see how that works. 5 plus 6 is equal to 11. And 6 plus 5 is equal to the same 11, no difference. 3 multiplied by 6 is equal to 18. 6 multiplied by 3 is equal to 18. 7 plus 9 is equal to 16. 9 plus 7 is equal to 16. 4 multiplied by 7 is equal to 28. 7 multiplied by 4 is equal to 28. But not so for subtraction and division. Be very careful with that. 7 minus 4 is equal to 3. But 4 minus 7 is not 3. It's actually negative 3. And 6 divided by 3 is equal to 2. But 3 divided by 6 is not 2. It is 0.5. So this commutative property holds true only for addition and multiplication, not for subtraction and division. Distributivity. Now, the distributive property, multiplying a sum by a number, is the same as multiplying each addend by the number and then adding the product. For example, if you add B and C first and then multiply by A, you will get the same answer if you multiply A by B first, which is this, and then you multiply A by C next, which is that, and then you add them. 2 multiplied by 4 plus 3 is equal to 2 multiplied by 3 plus 2 multiplied by 4. Let's see how that works. 2 multiplied by 7, that works out to be 7, is equal to 6 plus 8. So 2 sevens would give you 14. That's the left-hand side of this equal sign. And 6 and 8 will give you 14 as well. That's the right-hand side of the equation. Example 2, 4 multiplied by 5 plus 6 is equal to 4 multiplied by 5 plus 4 multiplied by 6. So 4 multiplied by 11, that gives you 11, is equal to 20, 4 5 is 20, plus 6 4 is 24. So 4 11s, 44, 20 plus 24 is 44. So you could see that the left-hand side of the equation is equal to this should be right-hand side. Left-hand side is equal to the right-hand side. That is right-hand side. Next one. 5 multiplied by 2 plus 3 is the same as 5 multiplied by 2 plus 5 multiplied by 3. If you work that, you are going to get 5 times 5. And if you work this part out, you are going to get 10 plus that part, which will give you 15. So you get 5 5 is 25 on the left-hand side, which is equal to 10 plus 15, 25 on the right-hand side. Would this distributive property of multiplication be valid over subtraction? For example, if you are subtracting C from B and the answer you get, you then multiply by A. Would that work if you multiply A by B first, then multiply A by C next, and subtract this second answer from this first one? Will it work? And the answer is yes, it will work. So that is true. The distributive property of multiplication over addition works, and the distributive property of multiplication over subtraction also works. So how well did you learn this? Match the letters of the items in column 4 with the examples given in column 3. An item may be used once, more than once, O-N-C-E, more than once, or not at all. So this is a table. You have question 1, 2, 3, and so on. You have to put your answer in this column. Here are the examples in column 3. And these are the properties as we learned them in column 4. First, we talked about closure, then associativity, then additive identity, then additive inverse, multiplicative identity, multiplicative inverse, commutativity, and distributivity. All right. You notice that we have 8 items in column 4, and we have 10 items in column 3. And it does say that an item may be used once, more than once, or not at all. So let's see. This first one here. 5 plus 2 plus 4, is that the same as 5 plus 2 plus 4? It is. But which one of these properties or operations are we dealing with? We want to put the letter here. All right, I'm giving you some time to consider it. All right, it is B, which is associativity. Next one, question 2. 412 multiplied by 1 is equal to 412. That one is one of the easier ones. Go through the list and tell me which one it is. All right, it is E, multiplicative identity. Next one. 2 multiplied by 3 plus 4 is the same as 2 multiplied by 3 plus 2 multiplied by 4. This one will take a little more work. Okay, the answer is H, distributivity. 4, 5 multiplied by 1/5 is equal to 1. Waiting for your answer. All right, it is F, multiplicative inverse. Question 5. 5 multiplied by 2 plus 3 is equal to 5 plus 2 multiplied by 5 plus 3. This is one that we have used before. Okay, the answer is H, which is the same one as that, which is distributivity. Next, number 6. 5 plus 0 is equal to 5. 5 plus 0 is equal to 5. This one should be very easy. All right, your answer is C, additive identity. You add 0 to anything, you get back the original number that you added it to. 7 plus 3 plus 1 is equal to 7 plus 3 plus 1. And the answer to that is B. We looked at that before, the first one here, which is associativity. Next one, question 8. 7 plus 9 is equal to 16. 9 plus 7 is equal to 16. Answer to that is G, commutativity. Number 9. 19 times 1 is equal to 19. We have seen that before in this exercise. Answer is E, which is multiplicative identity. And lastly, 5 plus negative 5 is equal to 0. D, which is additive inverse. So I hope you are now clear on these 8 concepts. And if not, as we go along, we will keep mentioning them and using them. So objective 1.10, use properties of numbers and operations for computational tasks. And that brings us to the end of this video based on Objective 10, Section 1.